This is a piece of fire-resistant plastic film. To make such films fire-resistant, flame-retardant additives like aluminum hydroxide are added during manufacturing. In this video, Raman microscopy will help us visualize and verify the presence of flame retardant in the sample, a typical quality control application. To do this, we take the sample and place it under the RAMANtouch Raman imaging microscope without any prior sample preparation. Next, we use the mouse to move the sample stage and activate the laser. We will use Raman line imaging, a special, very fast measurement technique that collects 400 measurement points per scan while moving the laser line across the sample. Next, we set the Raman measurement parameters with the help of the live spectrum until the Raman peaks clearly stand out from the baseline. After that, we select a region of interest on the sample. In this area, we will reveal the distribution of the chemical constituents. Then we start the measurement. Since we are using Raman line imaging, we can analyze large sample areas in just a few minutes. Already during the measurement, we can see how a colorful image with a very high chemical contrast emerges from the gray, low-contrast surface. While the base polymer remains dark gray, we can see three types of particles stand out in the image. We use a spectral library search to identify each one. Red is the expected aluminum hydroxide. Green, ammonium aluminum sulfate, another flame retardant. And the blue spots are actually large pigment particles. Especially for inorganics, Raman is an incredibly valuable tool and can detect many additives and fillers within a polymer matrix. Thank you for watching and see you next time.